Hello, my name is Vincent Zhu, and this is my video lab report for Physics 2112 Lab 1, Charged Tapes. So what was this lab? Throughout this lab, we started by charging two pieces of tape, and we placed them near everyday household objects to see if they would attract or repel in order to determine the charge on the tapes. And in the end, we repelled the two tapes with each other and floated one above the other. So why did we do this lab? I think that this lab is a great and simple way to visualize how charges react with each other using everyday household objects. In order to, we used Newton's second law, which states that the force on an object is equal to its mass times its acceleration. And we also used Coulomb's law, which is F equals kqq over r squared, during our calculations in order to determine the charge on the tape. So what were the materials that we used? We used tape, a ruler, a pen, and a book. And I took some initial measurements. For example, one of my tape lengths was 20.5 centimeters, and the other one was 21.9 centimeters. And we calculated the mass by assuming that a meter would be about a gram. We also measured the distance at which the tape started repelling each other, which was about 1.8 centimeters. So the first thing that we did was we charged our two pieces of tape by sticking them to a separate base tape and pulling them off. And as you can see here, the tape was attracted to my hand. The two tapes repelled each other, which is what we expected because we knew that the tapes had the same charge. And finally, it was also slightly attracted to the book. And it also repelled the pen, but that took a few tries, so I don't have a recording of that. So for the final part, I have a picture on the right is a diagram of the model I used, and on this diagram, I drew a free body diagram on here with two circles representing the centers of the tapes. And on the tape at the top, there are two arrows of the same magnitude but opposite direction. And we have this because for the tape at the top, it's not moving, so the momentum is zero, and that the net y component is zero. Therefore, we knew that there were only two forces on there, by the way, which was in the vertical components, which was gravity and tape A. And we knew that they had to be equal because the tape was not moving. And in order to calculate the gravitational force, it was pretty simple. We took the mass and we multiplied by gravity, which is 9.8, and we got 0.02 newtons. In order to get the electric force, we knew that it had to be equal to the gravitational force in order to cancel out, so we knew that it was also equal to 0.002 newtons. And I have a picture here of the model that I used. It's not very clear, but you can see that I have the tape on top, and I just put the tape under it, and it repelled the other one. So there were a few calculations that we had to make in order to find the charge. We knew that Coulomb's law is kqq over r squared, and also the force equal to the charge multiplied by electric field. So and E can also be rewritten as kq over r squared, and we multiplied we knew that the two q's were the same, so we knew that the equation was kq over r squared. And in order to solve for q, you just get q on one side by itself and square root the other side. So we got negative 8.79 times 10 to the negative 9 coulombs as our charge, which is quite reasonable. In order to get the number of electrons, we divide by the charge of an electron, which is 1.6 times 10 to the negative 19, in order to get 1.7 times 10 to the 10 electrons. And number of atoms is, we took the surface area of our tape and we divided by the area of each atom, and we got 5.58 times 10 to the 17 atoms. And our ratio of electrons to atoms was 3.1 times 10 to the negative 7, which is also quite reasonable. For my glow script, was pretty simple. It was pretty straightforward and close to the lab, and close to the calculations that we did earlier. I used this mainly just to check my calculations by starting with just inputting the constants of the tape distance, the tape length, and we solved for tape mass, gravitational force, electric force, and then in the end, I also drew we also have a diagram on the right of the two tapes with arrows pointing up and down in this just to show the free body diagram once again. And in the bottom, you can see that I printed out the electric force that I found and the charge on the electron, which is equal to the calculations I did earlier.